So my topic of presentation is tokenized vault. And here we would basically see why do we need vaults and what are the basically standards for the vaults and how we can scale them. If you look at the agenda for the complete talk, so it is going to be like this. Basically, first would be the need of the ERC standards for tokenized vaults. Then we have two different ERCs over here. First is ERC-4626, which is very much popular. A lot of protocols are using it. So a lot of you might already be familiar with it. And the second one is the ERC-7540, which is basically a scaled version of ERC-4626 for a specific reason, and we'll look into that. And then we'll look into the methods of these ERCs, and we will have one case studies for both of these ERCs basically. Okay, so first, like, why do we need ERC standards, right? So when DeFi boomed, right, we had different protocols: Uniswap, Aave, Compound, right? And those all protocols were basically giving the users receipt tokens or LP tokens as a proof of deposit, right, or lending. So and we have different protocols which basically integrate these protocols in their own protocol, right? So when we have different protocols and they don't follow some kind of a standard, right, integration becomes very difficult. So one of the main purpose of having ERC standards for vaults is like having a integration mechanism available or integration interface available for different protocols, so that the integration effort is much low, and we can also develop more consistent and robust yield bearing vaults basically. So that because Uniswap, Aave, and Compound, they have very different implementations, and each and every protocol which basically integrated with these protocols has to go through different interfaces and work according to them, right? But since the arrival of, let's say, ERC-4626, it's pretty much a standard, so something similar to ERC-20 that we have right now. So the first question, why we need it, it's basically to have a lower integration effort from the vault side. Okay, so first we start with the ERC-4626, right? So it's as we already talked about it, like it's a standard for tokenized vault, and it's mainly used for lending markets, aggregators, and we can like, for example, ETH bearing tokens, right? We can use it for all these different kind of protocols. And this particular ERC inherits ERC-20. So it's ERC-20 token, but it has some different methods added to it, which makes it different from the ERC-20. And ERC-20 tokens, basically here, they represent shares as a vault, right? And the methods that are added on top of it are like deposit, mint, max mint, withdraw, and some other methods, which we'll talk about later. And why do we basically have this way of like for the standard? So for example, let's talk about a scenario. Like we have a vault, and 10 different people deposit USDC to it, like 10 USDC every person, right? And those 100 USDC is being, deposited to some other platform to earn some yield or some rewards, something like that, right? And when those rewards are returned back to the wallet, we have to distribute that reward to each and every user, right, who participated or deposited in this particular wallet. Now to manage the the how do we redistribute the yield that we earned, we can do it like in two different ways. One way would be like we can keep separate record for each and every user. Okay, this user deposited this much and earned this much, so we'll give them back this much, right? This can go on for like 10 users. Okay, but what if they are like 100 users, thousands users, right? Then it will be very expensive gas wise, right? So to basically mitigate this situation of not having such gas expensive operations, ERC-4626 basically makes it easy for us to just update two or three values, right? What is the total deposit? What is the total asset? What is the total shares minted, right? These two or three things makes it very easy for us to calculate, okay, what is the share worth and how much is in every user is going to get from the yield that has been accumulated over the time, right? So yeah, ERC-4626 basically make it really gas efficient for everyone's shares, and yeah, it is one of the advantages of having this particular ERC. So there are different implementation for this ERC, and we have one from OpenZeppelin, and we have one from Solidity, we have from Solmate, They have a few differences like in terms of gas optimization and stuff like that, but basically the standard is going to be same. They will have the same methods. Yeah. And if we talk about the high level workflow of the ERC-4626 vault, so it would be like this. So there will be user who will deposit and they will get some shares, like those shares will be minted to them. And the same user can basically later on redeem their shares and they will get back the assets that they deposited plus some yield. And from where they're getting these yield, the vault basically deposited those asset to some yield strategy. For example, let me say we developed a vault and that vault deposited all those funds or lend all those funds to Aave, right? And after some time we will have some rewards at Aave, right? We can claim it back to our vault and reward our users. So yield is returned and that is what's returned back to users upon redeem assets plus yield. So this is the high level workflow of vault. But how does that happen? This basically basically two different methods for that, which we use. First is like deposit flow, and the second would be the withdraw for this. So yeah, so if we let's say have a contract which says that it implemented ERC-4626, so how would we know like which particular asset is being deposited over here or which asset is being redeemed? So we simply have a method called asset and we can check it from there, right? And how will a user deposit? There will be two different methods, deposit and mint. So you can either go for the deposit method or the mint. The difference is like if you go for deposit, you basically choose how many asset you are going to deposit, and the shares are minted, basically calculated or depending upon the amount that you have deposited and sent to you, right? If you'll go for mint, you basically choose how many shares you want to mint, right? And then on based on that, the assets will be calculated and that many assets with it involved. So, I mean, you have some methods, preview methods basically to calculate the shares and the assets beforehand to, before you can deposit or a mint. So we have the preview deposit and preview mint basically for that. And finally, we have convert to shares. The convert to share is the underlying method, which basically helps preview deposit and preview mint to, calculate shares or calculate assets, whatever user wants to deposit in this case. So next we have the withdraw flow and method. So in here, okay. So let's say a user deposit, right? Now, how will the user know how many shares they got? So they have the simple method of balance of, right? They can use this method and check, okay, these many shares they got, or the total shares that they have at the moment, right? And if they want to redeem those shares or withdraw some amount, they can basically use two methods. Method withdraw, where they will specify how many amounts of assets they want to withdraw, and the shares will be calculated on basis of that and burned. Or they can go for the redeem methods where they can specify the shares, like, okay, I want to burn these many shares, and they can get assets based on that. Similar to deposit, we have two different preview methods where we can basically, beforehand check, okay, how many shares will have to burn or how many assets will I get if I burn these many shares. These methods are preview withdraw and preview redeem. And the method which basically help these methods to calculate is convert to assets. It is the underlying method. So we talked about two different methods, deposit, two different flows in, I would say, deposit and withdraw in ERC-4626. And this is the high level view of the ERC-4626. So if we like, there are different methods, many more methods in here, but we saw most of them. And we can see, okay, how many of these methods will change the state and how many of these methods are just few methods. So moving on, we have the case study for the ERC-4626 MaxAPY. Okay, so what is MaxAPY? Basically a vault. I mean, we just discussed like one standard for vault, right? So this particular protocol uses that ERC-4626 standard to implement a vault, but they have different yield strategies integrations, like many yield strategies integrations, which basically boost the yield or the rewards for the users, right? So they have two different vaults, one with ETH and one with USDC. So basically in one of the vault, user will deposit ETH, and those ETH will be further deposited to some 10 or 20 different protocols. And from all those protocols, this particular MaxAPY vault will get the yield and redistribute to users. Similarly for the USDC. They are deployed on multiple chain, and if we look at one of their particular strategy over here, so if you see over here, right, can you identify what is the vault, what is the asset, and what are the strategies over here, right? So yeah, I think you might have already guessed it, but yeah, here WETH, USDC, these are the assets for that particular vault. And we have the first vault as Ethereum WETH, that is one vault, and Ethereum USDC. I mean, deployed. This particular vault is deployed on Ethereum, and the asset is USDC. And these are the strategies: convex, sommelier, yearn. Right? These are the different strategies where the user's deposited asset is further distributed for yields. So we have 4 different vaults over here on 2 different chains, and I mean, right now we only see convex, right? But if I remember correctly, they have like 4 or 5 different sub vaults basically in convex itself, right? So it's not just one yield strategy; it's like 4 or 5 inside convex, and similarly for familiar and yarn. So yeah, it was a lot of strategies to manage, but yeah, basically ERC-4626 allows it very easily for users to integrate with different protocols, and yeah, and manage the yield and redistribute it to users very easily. So I think that is it for ERC-4626. And yeah, now ERC-7540. So ERC-4626 was the basic one, right? Quite popular, everyone knows it, and being used around a lot, right? The next one, ERC-7540 here, is basically for one reason that ERC-4626 doesn't does, right? It is atomic deposit and redemption. So what do I mean by that? So ERC-4626 basically forces a user to deposit some assets and get some shares, and that's it, right? And when they want to withdraw or redeem, burn their shares and get back the assets. That's it. But what if there is a scenario where user deposits but doesn't want to wait for the share that is minted, right? I mean, the share can be minted later on, based on some other situation, right? For example, cross-chain lending, right? A user deposits some fund on Ethereum, and those funds get transferred to Base or Polygon or Arbitrum, and based on those, depositions, shares are minted and given back to users again on the Ethereum side. If what if like this is the flow that user, I mean, the protocol provides and user likes it, right, or user wants it. So in case of cross-chain lending, or let's say RWA assets, where finalization takes time, or some kind of uncollateralized loans, in these scenarios, uh, atomic deposit or redemption doesn't work. We want a system where there could be some waiting period involved, where the user deposits and when the shares are made, right? So for that systems, we basically have ERC-7540. Similar to like ERC-4626 is an extension of, we can't say extension of, basically it builds on top of ERC-20. But in this case, ERC-7540 is an extension of ERC-4626. But what it does different is asynchronous deposit and redemptions. And how does it do it? It is done using something called request. So what is a request, right? So a request is basically the start of a deposit or a start of a withdraw. So a user is going on the platform or on the protocol and starts the deposit process by depositing some assets, or starts the withdrawal process by burning some shares, right? This is how a request starts. Whereas in ERC-4626, those shares are burned and the assets are returned to the user in the same transactions. And or in case of deposit, the assets are deposited and shares are minted for the user in the same transaction. In case of ERC-7540, when a request is made, the state of the request is in pending. So yet no shares are minted for the users, or no shares are burned for the user, right? So the request is in pending state. Now the protocol process that is state, based upon the code logic or howsoever the protocol wants to process it, the state will go into claimable state, right? And when the state is in claimable request state, then the user can go back and basically claim it. And once the user has claimed it, it will be in claimed state, and that will be the final of the either the deposit flow or the withdraw flow. So as we can see it already, it's not atomic, it's async in case of deposit and withdraw flow. So if let's say a protocol has implemented ERC-7540, it should have these things for sure. First thing, like either deposit or redemption has to be asynchronous. It's not like they have to have both of them asynchronous. They can have either of them asynchronous. But if none of them are asynchronous, it's just basically ERC-4626, right? We don't need ERC-7540 in that case. Okay. And if they have gone for async deposit, what should happen? Like when the user deposits on Mint, so in the deposit method, it should not transfer the assets. The transfer of assets should happen in the request only. So as we saw earlier, like when a request starts, the asset is deposited, but shares are not minted, right? Similarly, in the deposit method, there will be no transfer of assets. And similarly for withdraw, like there will be no transfer of shares to the vault. It will happen in the request itself. Now we'll look at the deposit flow and the methods related to it, right? So how would you create a deposit? I talked about it earlier. We go with the request deposit method. We mention how many assets we want to deposit, who will be the controller of these assets, and who is the owner, right? From where the asset is going to be deducted, right? So anyone who calls this method, the asset will be transferred from owner to the vault, and the request will be in pending state, right? And this request will be in pending state until the vault somehow puts into claimable state. It will depend upon the logic of the vault. And once that is done, the request is in claimable state, the controller can finally come and call the deposit or mint method and basically claim the shares that were minted for that particular controller. And finally, the request will be in claimed state. So anytime you want to check, what is the pending deposit request amount, or let's say what is the claimable deposit request amount, we have these different methods for that particular reason. Similar to deposit, with the withdraw, if you see, we have request redeem method. So when we have request redeem method, what basically happens is like the user mentions the amount of shares that they want to burn, the controller and the owner, right? And the shares are transferred from in the request redeem method only. The shares are transferred from the owner to the vault, and again the vault process that particular request and make that into the claimable, and finally the controller can call the redeem or withdraw method to receive back the assets for the share that they burned earlier. And at any time we want to see the pending redeem request, how much is it, how many shares are pending yet to be redeemed, or how many shares are in the claimable state. We have these different methods to check it. Okay, just in the diagram, the same thing that I talked about. User calls request deposit and sends asset, and then deposit pending. Basically, vault process that particular pending deposit, puts it in claimable state, and finally the user can come and claim the shares. So in deposit, requests are sent in the request deposit method, and the shares are claimed in the deposit method. And similar in the redeem process, request withdraw basically logs the shares, and finally in the redeem or withdraw method, user gets back their assets. And that's the two different methods. And there could be sufficient amount of time difference between these two methods, and one cannot guarantee how many shares the user is going to get for depositing certain amount, or how many amount they are going to get for burning a certain amount of shares, right? It depends upon the situation, different situations the market is in. So yeah, similar to MaxAPY, we have a different protocol called MetaVault, and they are built on ERC-7540. And what they do is basically they allow cross-chain yield aggregation. So MaxAPY that used ERC-4626, they were limited to one particular chain for the yield aggregation, but ERC-7540 allows this particular protocol to aggregate yield over cross-chain. So for example, someone can deposit USDC on base chain, right? But those USDC can later later on get invested on Polygon or Optimism or Ethereum, right? And rewards can be accumulated, and finally they can be uh, on base chain and given back to the users. So ERC-7540 basically allows this to be done. So they are deployed on 7 different chains. I mean, the single protocol is on 7 different chains. It's not like we have different contracts deployed on different chains. It's the same protocol managing on 7 different chains. And again, they have 2 different vaults, ETH and USDC1 as the assets. And for the cross-chain operations, they use Superform protocol. So Superform is another yet very popular protocol, which already allows cross-chain operations. But this protocol basically uses their investment and divestment and liquidation procedures to help ERC-7540 to invest or divest or liquidate cross-chain. So if we look at the MetaVault deposit flow, as we talked earlier, right over here, like it for a protocol which implements ERC-7540, they can have one or both as asynchronous, either deposit or redemption, right? So so MetaVaults follow something similar. It has 2 different methods for request deposit and deposit, but whenever a user deposits, they basically use multi-call, and it seems like a single transaction for the user's perspective, and there is nothing async from the user side. So a user deposits to the MetaVault and they get back their shares in the same transactions. So for them, it will seem like a ERC-4626 operation. But the vault implements 2 different methods, but not using it from the perspective of ERC-7540 yet. But when we go to the withdraw flow, this is where it becomes a bit tricky, and this is where the proper use of ERC-7540 is here. So let's say if I'm not sure if it's clear, but we'll start from the first bar over here, user, right? So our user request for redeem for some particular shares. So those shares are logged in the MetaVault. It can either be logged or it can be burned. The ERC basically recommends to burn it, and in case the request or redeem fails, we have to remint it for the users, right? In case it fails, so it can be logged or burned. And once that is done, the vault checks if the vault has enough funds to fulfill the redeem request for the user. If it has enough assets, it will put the request in claimable, and the user basically can call the redeem method, and everything will be done there only, right? But let's say the vault doesn't have enough assets, right? User requested for $1,000, the vault has $400, so now vault will have to request a redeem, a cross-chain redeem, basically in this case for $600. So how did that happen? Okay, so vault will basically create a pending redeem request. Now, this request will be in some kind of queue, which a relayer will later on will check and process this redeem request. It will basically call the ERC-7540 engine, and this engine will initiate the cross-chain withdrawal. So it will basically call the Superform gateway, and this gateway will call the another chain and send all the withdrawal request and everything. And cross-chain vaults will basically return the assets to the Superform gateway, and from the Superform gateway, it will be returned to the MetaVault. Now, MetaVault will check again if it has enough assets to return to the user. And if there is enough assets, then it will update the request from request to claimable. And now user, upon seeing, okay, they can now redeem because their request is in claimable. They can go for it. And yeah, upon redeem, they will get back the assets and their shares will be burnt. In case this fails, the user's shares are minted again or given back to the users. So the counting is not wrong. So this is how the complete withdraw flow works for the MetaVault, and it is async in nature. Whereas the deposit, which is implemented in the async way, but is not actually doing that, because using multi-call we can do it in one particular transaction. But for the redeem, in case not enough assets are present in the vault, it has to be in the async way, and it is happening because of the ERC-7540, right? ERC-4626 won't be able to do it, won't allow it. So if we basically check, for the difference between ERC-4626, the major one is, in ERC-4626, there is instant deposit or withdrawal that we have to go for. 7540, we have the async one, right? There are no states in ERC-4626. Here we go from pending to claimable to claimed. And so some other difference that we have already talked about. Definitely ERC-7540 is much more complex, requires much more gas, and this shared calculation is not, fixed in ERC-7540. So a user, might get less assets or less shares than they are expecting. Still, we have slippage control over here, so that users are not getting completely rugged in this particular scenario. But the amount of shares or the amount of assets that are going to get changes, and it's basically decided at the claim time. So, and these were the main differences between the ERC-4626 and the ERC-7540.